Calculus! This is AP Calculus Lesson 4-9! Triangular related rates. We are at the end of our unit guide. 4-9, there we are. We have self-checks tomorrow on Friday. Monday is more self-check. Tuesday is pre-test. Wednesday is fix-up. Thursday is the test. We know what we're doing. All right, what's the Pythagorean theorem? Go! There it is. A squared plus B squared is equal to C squared. And of course, when I'm talking about that A, B, and C, A, B are the legs, C is the hypotenuse. If you want to go ahead and draw yourself a triangle, let's see if my technology can handle it. My technology cannot handle it.
It has to be a right triangle.
It has to be a right triangle. It does. It has to be a right triangle. A and B would be like the legs, and then the C would be the hypotenuse. Just making sure we know that. Cool. Now, let's take the derivative with respect to time. We'll just leave it A prime. Just assume that we're taking it with respect to something not with A, B, and C in it.
Would it be 2A plus 2B equals 2C?
It's 2A.
I left it just in case I
B prime, C prime, like that, yeah. Okay, let's go ahead and simplify. How can we simplify that? You can do something about the 2, yeah. Let's do something about that. What are we gonna do to them? We're gonna just, okay. We can divide by 2. We could have beaten them up, but let's go ahead and just divide.
We're erasing him
Well,
from existence. That's probably good now.
That's good. Yes, B prime is equal to C prime. Oh, and that lines up for a star. That's a formula that you can memorize.
It didn't line up for the star.
Oh, you didn't line it up? Okay, it lined up for me because I knew what I was going to do, but there it is. It's something that you can memorize, but you know the Pythagorean theorem. It's a review from way distant geometry, maybe even 7th grade. I don't know when you learned it. You've known it in your hearts forever because you think about it every night before you go to sleep, and you can just say it here. You can take the derivative. I know you can do that. You know how to divide by 2 by now, I would hope. So there it is. There's our formula. We're going to use it over and over and over and over and over and over again. So example 1, we have a falling ladder problem. Today, by the way, is the one related rate day where we have 2 examples. There's one on the back. So let's go ahead and talk about a falling ladder. And AP tests love the falling ladder problem. You'll probably see it on the test.
Or sometimes we do shadows.
Shadows are popular on just triangles, but in terms of the AP test, falling ladders are super, super popular. So, reader, all of us have beautiful voices. Which of these 3 beautiful voices will be reading for us?
You have a voice too, you know.
I do, and it's awesome. But I want another awesome and beautiful voice aside from myself to do this because I'm the one that usually talks mostly in this class. I want to.
It's not like the microphone can hear us from over here anyway.
Then speak loud, speak proud. Come next to me and maybe speak loud and proud. I don't know.
I guess no racist accents because we're posting this on YouTube.
That is also true.
Wait, what?
No racist accents. Yeah, don't pretend to be Indian or Sri Lankan or whatever.
All my accents are racist.
Okay, maybe we should do that.
But they're good though.
I could do my radio announcer voice.
Yeah, that's pretty.
All right.
Or try British. How about that?
I cannot do British to save my life. Nope. And I literally, it would not be able to save my life. They're like, hey, your life now depends on your British accent. I'm like, just kill me now. Okay, sorry. All right, let's just do some fun accent. The top of a 10-foot ladder is sliding down a vertical wall at a constant rate of 12 feet per minute. When the top of the ladder is 6 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? And there's my accent. All right, so how are we going to do this? Let's always start by doing what? Every single time you start with a related rate, you list things that you know, and maybe even before that, especially for these triangle things, draw the image, draw a picture. Yeah, exactly. Let's go ahead and draw a picture, and then our next step will be labeling things that we know. Let's draw a picture. And if you just want to draw the picture and say A, B, and C, and then label A, B, and C over here, you can. But I'm going to draw my picture and label everything about this problem on the picture because it'll be hard to see, like, what is A, what is B. We don't have variables for this one, so a picture is more important when we're talking about anything with triangles in it. We don't know which leg is which leg. So I'm going to do color-coded. Blue means it's a fixed non-rate. It's just a distance. And if I do red, I'm going to say that is a rate. That is moving. All right, so what should I be labeling about this diagram?
Well, C equals 10 because the ladder's 10 feet long.
Yeah, ladder, you can't change that unless you have one of those slidey ladders that actually like can change sizes. But usually you're going to have a fixed length of 10 there.
And then the bottom would be 12 feet.
This bottom is 12 feet.
Or no.
Oh, we don't know. We want to know the bottom.
Yeah, we don't know the bottom right here.
So
Well,
then,
That's what we want.
so then would it be the short leg?
short leg right here
6?
is 6. Yep. Because it says when the top of the ladder is 6 feet from the ground. So right before it touches the ground, 6 feet before it hits the ground, it's right there, 6. We have some other information that I can color code in red. What is my red color coded thing going to say? Where is it going to go? This 12. Where does that go?
It's like A prime.
Oh, that would be
A prime. It's one of the legs, right?
Yeah.
Which leg?
The one with the 6 foot.
The one with the 6. So I put a 12 here. So putting a 12 there is slightly incorrect. Someone tell me why.
because it's sliding down.
Negative 12.
Negative 12. Exactly. Yeah. It is a negative rate. This distance is decreasing. So it needs to be a negative. Be careful with your negatives and positives. So here we go. Now we can plug in everything that we know. I'm going to go ahead and arbitrarily say you are going to be A, you are going to be B, and you are going to obviously be C. And I have my formula. I'm just going to go ahead and rewrite this formula again down here. So let me, that's not what I meant to do. So now I have, come back here, pencil U, A prime plus B prime is equal to C prime. Okay, let's plug in everything that we know. We have an A, that's our 6. We have an A prime, that is our negative 12. Got some lag there, negative 12. All right, and that's going to be plus. We know B? No, we don't know B. I'm just going to call it B. Do we know B prime? Oh man, we don't know B prime either. I'm going to do that in red. We don't know B prime. Darn it. Uh-oh. 2 variables. Something bad is happening here. I need to say that this is now equal
We
to...
can plug
Yeah,
it
we
into
can
the
find B
Pythagorean theorem and find B.
Ah, so we can find B. So let's go ahead and find B after we finish plugging in everything that we have. What is C? C is 10. What is C prime?
It's not changing.
It's not changing. Therefore, C prime is...
Is it 1?
Or is it 0?
Yeah, it's a good question. 1 or 0? I don't know. I do know. I'm just like pretending to not know, so you guys figure it out. What is C prime? Rochelle, you haven't weighed in yet. What is C prime? How fast is this 10 changing?
It'd be 0. Would it?
Or is it changing? Is it so? She votes 0.
I think
Arrow?
it's 0.
0.
Because if
0.
It's 0 because it's the same. So it's the same 10-foot ladder, but the only difference is changing is just the rate of its falling.
Exactly. Yeah. So 0 means it's not changing. And I kind of misspoke earlier. I shouldn't say how fast it's changing. It's asking, is it changing? Is that a number or is it 0? And it is 0. So there's my 0. Ah, that's so nice. 10 times 0. Okay, that's just 0. Nice. All right, so I'm going to rewrite this equation down here in a random different color. 0 is equal to, and then I know what 6 times 12 is. It is negative 72. There it is. Okay. And you guys told me we can find B. We know B because we have the Pythagorean theorem, the normal non-derivative form of that. And you should know this one off the top of your head. Boom. It's one of the Pythagorean triples that you need to have memorized in pre-calculus.
what? 6, 10.
I feel like it's 4. It might not be 4.
All right. Name all of your Pythagorean triples. We'll list them off to the side.
30, 60, 90.
No, that's 30, 60, 90. Pythagorean triples are
Oh, they're just side lengths.
side lengths. Yeah, side lengths. What side lengths do you remember that are right triangles?
3, 4, 5.
There it is. 3, 4, 5.
That's the one we heard.
That's the one you know. Cool.
And that's the one we're using.
What's another one that we have?
Was it 6 and 8?
Nope. Close though. Multiply every single one of these by 2.
Also, it'd be 6, 8, 10.
6, 8, 10. What's another one?
12, 16, 20.
There's one with 12 in it, yes. Something 12, something. You remember this one?
10, 12.
No, it's 5, 12. 5, 12. Take a guess. Take a guess. Or do the math. Or do the math. It's not 14. 5, 12. 144 plus 25. Take square root of that.
15?
What's square root of 169?
13.
There it is. 5, 12, 13. These are the three key ones that you need to know. AP test might have more than that, but usually those are a good three to start with. And of course, you can also multiply this one by 2, 2, 2, 2, and then you'll get a new Pythagorean triple, which is still, I wonder if there's a word to distinguish, like, we've talked about him before, it just hasn't been reduced. So in terms of reduced Pythagorean triples, there's only two that you need to memorize because 6, 8, 10 is just a multiple of another one. All right, so we know what B is.
10 is a multiple of 3, 4, 5.
Exactly, yep. So
There's really only two then, right?
yeah, there's only really two that you need to remember, and then you can multiply by 2. So this B we know because it's a Pythagorean triple, and it is
It's 8.
It is 8, yeah. So I'm going to go ahead and plug in 8 here. Let's go ahead and say plus. There is the new thing that we're plugging in. It's our 8, and we still have our B prime. Go ahead and solve for B prime.
It's
9. Is it 9 or negative 9?
9.
It is 9, yeah. I always love challenging people to see if they'll change their answers. But yes, you're assertive. It is 9, Mr. Sindel. It's not negative. What are you asking about? There it is, B prime.
With units?
Ooh, you caught a teacher error. Yeah, I boxed my answer before I had my units. Log it. What are our units here?
Feet squared per minute.
Feet squared per minute.
Right.
Is it squared?
No,
Is it squared or
it's
not
feet
squared?
per minute because it's the distance
It's
between the bottom of the ladder and the wall, which is
Yeah,
only one
it's
dimension.
Yeah. When would it be squared, Rochelle?
It was C. Well, what do you mean by the question?
So when do I have any? And it doesn't have to be this question in general, but in the context of all possible related rate problems, when will I have something squared per minute?
Let's talk about.
And then you can ask for help too. You can call on one of Ben or Arrow, and they can answer it too. Or maybe they can't answer it. Maybe it'll be
When you're measuring like a plane instead of a line, you use feet squared.
plane. Yeah, so area, a plane. So whenever area is being, when you're taking the derivative of area, the rate of the area, rate of an area will be feet squared. This is just length. Length will always be feet. And we know it's a rate because it's per minute, so that's why we have a prime.
So
So this isn't an area, this is just a length, therefore it's just feet. Yeah, questions still? Nope. All right, so there is our final answer. Now Mr. Sindel can box it. Oh, and just be careful here. So sometimes writing 9 feet per minute on the AP test and on Mr. Sindel's test isn't enough because you have to relate it to the context of the problem. For example, maybe you thought that this should be a positive 12 and you write a negative 9 here. But what does that really mean? What is happening with the direction of the ladder? Is the ladder going away from the wall or is it coming to the wall? What does this 9 feet per minute mean?
It's going away from the wall. The distance is increasing.
Okay, because of how we've defined the problem, that means that this is going away from the wall. Let's make a note of that. This is going away from the wall.
So they'll actually score that. You wrote that. If you write like away from wall, they actually score that.
Usually if you just say 9 feet per minute, you'll get the points, but sometimes if you accidentally decide to make this you forget to make it a negative 12, if you say away from wall and it's 9 feet per minute and you have the correct units, you can still get the points back. So if you just do both, then you're safe, right? As long as you know what's happening. But if you say negative 9 feet per minute towards the wall, then you have definitely made a mistake. Good, good, good. All right, back. The travel problem. I need a different beautiful voice because my beautiful voice read the last one. To read this one.
I'll do it.
Go for it.
Should I do it funny?
Sure.
But all my accents are racist.
Okay, then don't do racist. Just do your normal Ben voice.
Riley and Alex are in motorboats traveling in located.
Yeah.
Traveling moved up a line.
You're okay.
There are motorboats located at the center of the lake. Riley begins traveling south at a speed of 32 miles per hour. At the same time, Alex takes off heading east at a speed of 27 miles per hour. At what rate are they separating after 2 hours?
Yeah, okay, so boat problem. They're having in directions. And maybe it's clear to you what direction they're going, what type of shape they're making. Probably making a triangle. I don't know. Something about this lesson makes me think triangles.
They're
But
not traveling opposite directions.
yeah, but let's just make sure of that. My first step in triangle problems is always to draw a picture. Here's my picture. Broop, broop, broop. All right, there's my center. So they are located. There's my center of the lake. It's that point right there.
Wow, that's a big lake.
I mean, it's about that size, so I don't know.
No, I mean, they're for 2 hours. They're
Oh yeah,
traveling from the center.
definitely. Maybe they should be in the middle of the Atlantic Ocean or something. I don't know. I might need to change this problem to make more sense,
And
but
also, it's unsafe to separate. They should stay together.
yeah, that
On
might.
such a big lake, they should probably stay together.
That's true. It is a safety concern. I'm gonna go ahead and guess that this is a right angle. I'm just guessing this. Hopefully they're not going in opposite directions. If they are, then we have some weird things happening. Okay, so maybe my triangle here is wrong, and this triangle is wrong. And someone tell me why, and you get your teacher extra credit point. Why is that triangle wrong? In the context of the problem.
Because it's not south and east.
Yeah, it's not south and east. Let's go ahead and redraw the south and east. East is going to the right, so it should look like this. Go ahead and log it, Ben. There's my center of the lake. Make sure that you draw your picture correctly, Mr. Sindel. So now we have the correct picture, and I do want to redraw this so I can actually have some room to label this. And I should probably use these handy-dandy points that I have on here to make it a little bit straighter. All right, now, finally, third is the best triangle. What should I label? I have a top and a left. What do I label those things? In blue. Do I have anything that's in blue? Anything that's a fixed distance that I haven't taken the derivative of yet?
I don't think so.
Not yet. Okay, let's do red. What do we have for rates?
27 and 32.
27 and 32. We all agree? Making a face because of negatives.
Oh.
And it's up to you, because you get to define the perspective of your problem. Do you want that to be a negative 32, or do you want it to be a positive 32? It's up to you.
I think it should be positive.
Okay.
Yeah, let's not make it negative.
Okay, yeah, let's make it positive, because that distance is increasing. All right, so somehow we need to find distances, because remember, in our original problem, we need an A, we need a B, we need a C. We need all three of those in order to solve for what it's looking for. It's looking for a rate, so that means that one of these A primes or B primes is going to be the variable, which means every single thing else we need to find a number for. And by the way, I'm just going to go ahead and copy this down. A prime, B prime equals to C prime. There's a plus in there somewhere. All right, I have an A prime and a B prime. I'm looking for C prime. So C prime is going to be my box. I'll go ahead and make that a box in my picture. I'm looking at the rate that they're separating, this separation distance here. Somehow I need to find these lengths. How am I going to do that?
Multiply the rate by the number of hours.
There it is, rate by the number of hours. So if you're looking, and this is a little handy dandy formula on the side, distance is equal to rate times time. If you didn't know that, there it is. We're looking for a distance, and it gave us a rate, and it gave us a time. We just need to multiply those, we'll get the distance. So let's go ahead and do that. They are both going for 2 hours, so the time is going to be the same. So let's go ahead and do Riley. I'm going to do R. R is going to be 32 times 2. 32 times 2, which means we are where? 64 what?
Miles per hour.
Is it miles or miles per hour?
It's just miles. It's just a distance.
Yeah, we're looking for a distance here, so it's just miles. All right, where does that go? Does that go with the 32 or the 27? 32, so let's go ahead and say that goes there. 64. All right, let's go ahead and do Alex. What am I going to do for Alex? 27 times 2, which is
54.
54
Miles.
miles, and that goes with the 27. So I'm going to come up here and put a 54. All right, now we can plug a lot of things in here. We're still going to be missing one thing, and you'll probably see that right away. But let's go ahead and plug in everything that we have thus far. So we have an A, and do we care which one is our A? Which one should we make our A? Top or left? Okay, there's our A, there's our B, there's our C. So my A is going to be 54, so let's go ahead and plug in 54. That is going to be multiplied by the rate of 27. Lag there, 27. That's going to be added to our B over here, so that's our 64 there. And we're going to have to multiply that by, come on now, 32. And that is going to be equal to, we have no calculators, I know, I heard it. C times C prime, and we know, right, and yeah, so we're going to go ahead and just leave our C prime there because that's what we're looking for. We need to find C, and so it's a 64, 54 watt triangle. By the way, you might be able to reduce that triangle and then rescale it up by the same factor that you reduced it to. That is a little trick that you can use for these. Because this is not a reduced Pythagorean triple. You can tell because both of those are divisible by at least 2.
Oh.
If not 4. They're probably both, I don't know. They're not divisible by 4, I don't think. So let's go ahead and reduce them. Let's go ahead and do it over here. So when I make the smaller triangle, reduce the fraction 54 over 64. This reduces to, go ahead and do it on your paper. Divide the top and bottom by 2.
7 over 32.
Which we already knew because of the other numbers.
Yep. Does 27 and 32 reduce to anything? Almost, but no. You don't have to make it a smaller triangle if you don't want. If you just want to do these large numbers, this is still large, so maybe you want to just use the original. But if you choose to do these, you can find Pythagorean theorem and then find that missing length of C and then multiply by 2, or you can just do it with the 54 and 64. It's up to you. What are we going to do? Smaller one? Okay, so let's do it on paper. Here we go. Scratch work on the side. 27 squared plus 32 squared is equal to that missing length that we're looking for squared. 27 times 27. So I'm going to have a 9. Ooh, what's the best way to do this? I'm going to do it like this. 20 plus 7, 20 plus 7. 20 times 20 is 400. 20 times 7 is 140, 140, 49. Add all those together. That's going to be 680 plus this. That's going to be 729. Do you guys like my little box method? Have you done it before? Then I'm going to do 30 plus 2, 30 plus 2, make my box. 30 times 30 is 900. 2 times 30 is 60. 60. 2 times 2 is 4. 60 plus 60 is 120. 1020. 1024. It's equal to C squared. So now I have 1,700 and it's going to be 53. It's equal to C squared. I'm going to make an educated guess here. I'm going to guess it's somewhere probably between 32 and 35, I would guess.
We need that book that has all the
Yeah, one of us
square
has to
roots
be
of
the
things.
calculator.
All right, what ends, did I do that? Did you both get 729 and 1024?
Yep.
No.
Oh, what did you get? I don't know if I made a mistake.
I had some random numbers, but I was trying to balance things in my head at the same time, and chances are I made mistakes. So,
Well, because you know it's going to be a squared, what things end with a 3? 7 times 7 ends with a 9, for example. 6 times 6 ends with a 6. What ends with a 3?
That's a trick.
just anything.
And I can't think of anything that ends with a 3, which is making me think that I made a mistake.
Oh,
27
I got the same numbers.
squared. 32 squared. Oh, maybe this doesn't come out nice. I thought it came out to an integer. Maybe it does not. Let's use our handy dandy calculator. 1753. Oh, Mr. Sindel, why would you do that to us?
Try,
Oh.
We are
try checking
rounding.
your math
It's fine.
in case.
We'll just round to 42.
Yeah, that's okay. It's 42. 42 is a good number.
Yeah, so I'm just going to go like this. 1753. Square root of 1753. Is this really what we did last year? Yep, we did this. I should have made this problem way nicer. I must have made a mistake from copying John's notes. I feel like this is way too much. Anyway, let's go ahead and do this multiplication and this multiplication. So go through that. And again, the fastest way to do that is using your little rectangle. 50 plus 4 times 20 plus 7. That's going to be 1,000 there. 4 times 20 is 80. 7 times 50 is 350. 4 times 7
I see.
is
Just add
28.
those.
And then add them all up. So that's going to be 108 right there. That's going to be 458. 1,458. I'm going to do another one for 60 plus 4 and 30 plus 2. It's going to be 1,800 there, 120 there, 120 there. Wait. Yeah, that's interesting. And then 8 there. So 248, 2,048. Is equal to 1753, the radical version of that, C prime. Whew, we're almost there, we're almost there. We're so close. Now can Mr. Sindel add in his head correctly? You can check his math. I see a 6, I'm carrying the 6, and then I get a 0, carry that, I get a 5, nothing to carry. 3 is equal to 1753 radical C prime. And finally, C prime is equal to 3506 divided by radical 1753. And I'm not gonna, well, I guess I could rationalize the denominator. Do you remember how to do that?
Would it be using reverse to multiply up to 1753?
Yeah, you multiply the whole thing by square root 1753 over 17, square root 1753.
Yep. So 1753, 1753, multiply the square root of the top and bottom. And, oh my gosh, we're so close. Come on, Mr. Sindel, we got this. It's going to be 3506 times the square root of 1753. All of that divided by 1753. Oh! Hey! Hey! Do you notice something between 3,506 and 1,753?
Could it be that it's double?
It is doubled, yeah.
Wow,
That's cool. Okay, so that means
So it's just 2.
2 radical 1,753. But, the last step. Don't lose that 1 point. Units.
It's so easy to forget units after a intense problem
Yeah.
like this.
What are our units?
miles per hour.
There it is, miles per hour. Whew, so much math there. That was a good review, though. There it is. That's the final answer. I think for next year, I'm going to make this problem work out nicely. Because that's kind of like, I think that's more work than they would expect you to do on the AP test.
Chances are you said that last year.
Yeah, chances, and I should have looked ahead on the notes, but my notes were like on 7 different pages because it was so long. So I didn't see that it was that long. But now, this year, it'll be easy to see in 1 page, yeah, there was a lot of math that we had to do here. All right. So, any questions? There was a lot of math that we did. No questions on any of the math? All right, that concludes the notes.